Hello everyone, today we're going to be talking about the water cycle. I wanted to use this figure from the internet just because it has more information and a little bit better format, I think, than what your book does. So what we want to look at here today is how fresh water in particular cycles throughout the whole earth in different ways in order to provide the fresh water for the earth. As you know from your reading, or as you'll find out very soon, fresh water really constitutes a very small percentage of the Earth's water. Of course, this is the water planet, there's water everywhere, but much of that water is salt water in the oceans, which is not suitable for any living organisms, including humans, to drink and to use for their regular services. So we want to talk about how the Earth provides fresh water to us and every other living organism on the Earth. So we can start anywhere basically on this picture, but let's start over here. Let's assume that this area over here is salt water. So this is some kind of ocean, large bodies of water on the earth. The ocean gives up water to the atmosphere through the process called evaporation. So when surface bodies of water, and this doesn't have to be the ocean, this could be a freshwater pond over here as well. Any kind of standing body of water, even a puddle on the ground, goes through this process of evaporation. So as the sun heats up the water in the standing body of water, little particles, molecules of water, escape from the surface. They get enough energy to escape from the surface, kind of the equivalent of steam when you're boiling water. And the important thing to remember here is that when water leaves the surface water, it only goes up as water. That sounds obvious, but really there's lots of other stuff in this salt water system or in this lake system. There's minerals dissolved. In the case of the ocean, there's salt dissolved in this whole body of water. But as the sun increases the temperature of the water and those little particles of water escape, it's only the particles of water that escape. So it's completely fresh water. It's 100% water with nothing dissolved in it. So all the dissolvents, all the solvents are left over in this body of water, leaving this a little bit saltier every time the evaporation occurs. So what we have is completely fresh water being evaporated up into the atmosphere. So now these little particles of water become part of the atmosphere. They can conglomerate, they can get close to each other, they can build up and get heavier as more and more water molecules evaporate into this particular cloud, for example. And as they congregate and get heavier, under the right circumstances, they come back down to the earth as condensation. Now this condensation is 100% fresh, pure water at a good pH. Nothing's wrong with it. There's no pollution in there. So this is very, very important. If we did not have this process of evaporation and then condensation, then we would never, not the humans, not any other organism on the earth, would have any fresh water available for drinking and for survival. Now, living things are composed of 70% water. Every single cell in your body is 70% or more water. So you can tell how important this process is to us. So the precipitation comes down. When the fresh water comes down from the atmosphere, it should be 100% pure and clean. However, there can be some issues, which we'll talk about in the air pollution section. If we have air pollution in this area, then as the fresh water comes down, since water is such a great solvent, it can dissolve those pollutants in the atmosphere itself, bringing them back down to the earth. However, let's assume for our purposes right now that this is 100% fresh, pure drinking water that's coming back down to the earth. When the water comes back down, it condensates in the atmosphere, and then as it comes down, we call it precipitation. So this could be rain, this could be snow, sleet, hail, to some extent. This could be any kind of water or solid water that comes down from the atmosphere to the earth. We call that precipitation. So now when the water hits the earth, let's assume we're talking about liquid water here. When the water hits the earth, there's a couple of things it can do. First of all, it could hit an area like we have here with a lot of grass and a lot of ground cover that's maybe a little bit more solid, particularly grassy areas, or even in the case of humans and cities, it could be concrete and asphalt and things that the water just doesn't penetrate very well. If the water doesn't penetrate into the ground very well, then it tends to find the closest, nearest body of water, whether that be a puddle or a stream or a river, and it tends to kind of run off into that area. So it will run along the length of the land and down the hills and down the valleys until it finds the closest body of water. So if this rain is not able to enter the soil, it will enter the stream in this example, and the stream will run down this kind of slope of a land into the nearest larger body of water. In this case, it looks like a freshwater lake. So that's one option. When precipitation comes down, it could hit the ground. If it can't enter the ground for some reason, then it will run off into the largest body of water. The second option that the rain has as it enters the earth is it might fall into an area where it is able to go into the ground. So if this is regular soil with nice infiltration properties, where the water can actually enter the ground and go into the lower layers of the ground, we call that infiltration. So it's infiltrating or entering the soil. And as it runs through the soil, it actually gets filtered. So this up here should be 100% fresh, pure water. If for some reason it did pick up some contaminants as it was falling, or if from the soil itself it picked up some contaminants, as it infiltrates the soil, there are many, many layers of soil, including rock and gravel, until it gets down into what we call the groundwater system. And this rock and gravel system, the infiltration process typically actually helps clean the water even more, so that you get kind of a filter. That's why it's called infiltration, a filtering effect as the water moves down towards the underground water body system, which we could label down here groundwater. So this is the groundwater. As condensation and precipitation happens, it can infiltrate in some cases if it has an appropriate environment and become part of this groundwater body. So this is the underground water system. This is where you would tap into if you're drilling a well for fresh water. Here in Chicago, we don't have that necessity so much because we have a great, huge body of water called Lake Michigan that we can withdraw from. But in most of the country, in order to get fresh water, they have to drill wells into the groundwater system to tap into that fresh water. So the other option is, as rain comes down and precipitation happens, sometimes the infiltration happens into the soil, but it happens instead of a kind of open body, open area land, it happens in areas where there's trees and plants. And if infiltration happens and there's plant roots and trees in this area, then instead of going all the way down to the groundwater system, the water will enter those roots and trees, roots of the trees and plants. And when it goes into the roots, the tree will use it for its purposes, which is photosynthesis. One of the byproducts of photosynthesis is a release of a little bit of water. So you can think of this as the plants and the trees effectively sweating. As they go through the process of their metabolism and turning the sun's energy into glucose energy for themselves, which is photosynthesis, they leave off a little bit of water excess that has to be dealt with. And the way that that's dealt with is it's literally like the leaves are sweating. Little droplets of water come off the leaves. And those little droplets of water easily transpire, which is the equivalent of evaporation. As the sun hits those leaves, those little droplets of water will gain enough energy to go into the atmosphere as water vapor. And we call that process transpiration. It's just evaporation, just like we see everywhere else. But when it's happening in the process of photosynthesis with the help of plants and trees, we call that transpiration. So the plants are using the water that they need for their living. They're using it for photosynthesis, and they have a little excess water, just like we do. We evaporate off our skin. But when they evaporate, we call this special type of evaporation transpiration. So water in the form of precipitation can go into standing bodies of water from runoff. It can go into groundwater from infiltration, or it can go through plants and trees and then eventually evaporate back up into the atmosphere through transpiration. So this is the water cycle, and you can see that any one arrow leads to the others. Groundwater will eventually either be used and tapped into by humans, or it will actually flow into larger bodies of water, typically the ocean. They don't see a connection down here, but you see the subsurface flow of groundwater that has infiltrated and then released to the ocean. You also see large bodies of water that are fresh, eventually flowing into the ocean, and that ocean water then goes through evaporation. We can have evaporation off this body of water as well. We can have transpiration, but you basically see this big loop of fresh water moving into salt water and salt water evaporating, and then the whole process starting again. So it's really important to understand the water cycle, because when we get to water pollution, we're going to revisit this picture and revisit these issues, and we're going to talk about where pollution can gunk up the system and where withdrawal from humans can gunk up the system and really cause water shortages as far as fresh water is concerned for human use.